We are in section 6.3, proving that a quadrilateral is a parallelogram. Let's look at to solve it. Each section of the glass in the exterior of a building in Makwa, China, forms an equilateral triangle. Do you think the window washer's feet stay parallel to the ground as he lands on each level of the windows? Explain. Assume that the bases of the lowest triangles are parallel to the ground. So, we'll be exploring more about the angles and properties of quadrilaterals. Alright, so here's a theorem. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So, if the opposite sides of these are congruent, then that means that they're parallel and it's also a parallelogram. So let's look at two more theorems. Alright. If an angle of a quadrilateral is supplemental both of its consecutive angles, then the quadrilateral is a parallelogram. Alright, so that means if A and B are supplementary and C and D are supplementary, then therefore this is a parallelogram. Likewise, with 610, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if A and C are congruent and B and D are congruent, then therefore ABCD is a parallelogram. Alright, problem 1. I want to find the value of y for PQRS in order for PQRS to be a parallelogram. So that means in order for PQRS to be a parallelogram, that means that these two sides must be congruent to each other and these two sides must be congruent to each other. So that means that 3x minus 5 equals 2x plus 1. When we solve for x, x equals 6. So therefore, we found x, so that means these two sides have to be equal to each other. So that means that when we plug in y equals x plus 2, you get y equals 8. So therefore, PQRS, for that to be a parallelogram, y must be 8. So, I got it down here. Let me move over so you can see it. You can see a little bit better over here. That's a 3y. Awesome. Alright. And then problem 2 asks, with this information, can we assume that HIJK is a parallelogram? So that means these two sides are congruent, these two sides are congruent. And the answer is no, because the opposite sides must be congruent, not the adjacent sides. Not consecutive sides. Okay. Before we move on to the last problem, if one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. So that means that if BC is congruent to AD and BC is parallel to DA, then therefore it's a parallelogram. I'll go over problem 3 in class.